Hello everyone, this is lecture 23 for the classical physics. In the last lecture we discussed some questions. In today's lecture also we will discuss some more questions, because only the questions can give you the complete concept. Because when you learn different kind of questions and see different kind of questions, you will learn different kind of concepts. So when you see all type of questions, then you will get all the concept of Lagrangian. So that's why we are discussing more and more questions. So let's see some more, and these are the previous year questions actually. So let's see some questions. A bead of mass m can slide without friction along a massless road capped at 45 degree with the vertical as shown in the figure. So figure is something like this. Okay, this is vertical road and bead is here and it is rotating. Means this road is rotating and it is free to move on this road. The road is rotating about the vertical axis with a constant angular speed omega. At any instant, r is the distance of the bead from the origin. So you need to find the Lagrangian of the system, equation of the motion for the bead, and momentum conjugate to r. So let's see. What is given in the question is that this road is moving around the z-axis and this bead is free to move on this road. So this r can vary, okay, and this angle is 45 degree for this road and this is fixed, and angular velocity is omega. So we need to find first the Lagrangian of the system. So first let's see some constants. So this theta, if you see the spherical symmetry, then this will be theta and this will be phi and this is r. So r can vary and theta is 45 degrees, so theta dot will be 0 and phi dot is omega and this is angular velocity because, so this is your phi, so this is rotating like this, so phi dot will be omega. So we have these kind of equations. Now to write the Lagrangian, how can we write the Lagrangian? It is nothing but half mv square minus potential energy. So for the velocity in the spherical coordinates, we know what is velocity, that is r dot square means vr square plus v theta square plus v phi square. So it will be r dot square plus r square theta dot square plus r square sine square theta phi dot square. So I already told you how to get this expression. In the spherical coordinates, velocity is written like this. Now the potential energy will be mgh. So this height of bead at this point will be this, and this is nothing but r cos theta will be this height. So r cos theta is h. So that's how we can write the Lagrangian. Now we know what is theta dot. Theta dot is 0. So in place of theta dot it will be 0, and this theta will be 45 degrees. So sine 45 is nothing but 1 upon root 2. So it will give you 1 upon 2. So this equation can be solved to this form, okay, arranged to this form. L will be half m r dot square plus this will be 0 and this will be 1 upon 2. So r square by 2 sine square theta, and phi dot is nothing but omega, so omega square minus mgr cos 45 will be 1 upon root 2. So this is your Lagrangian. Now to write the Lagrangian equation of motion, you need to solve these differential terms. So del L by del r dot will be, from here it will be mr dot, and dy dt will give you mr double dot, and del L by del r will be from here r sine square theta, means it will be from here 2 will cancel out. So you will get this thing, means half m from here and r sine square theta omega. Okay, so this was a mistake. We already substituted the value of theta 45 here and we get this value as 1 upon 2. So this will not be here. Just remove this. So this will be your Lagrangian, and now del L by del r will be, from here it will be r omega square, and from here half m, so half m omega, r omega square, and from here you will get minus mg over root 2. So this will be del L by del r. Just now subtract this from this, so you will get the Lagrangian equation of motion, mr double dot minus this whole term. So this will be your Lagrangian equation of motion. Now third was we need to find the momentum conjugate to r. So what is the conjugate to r? Means whatever momentum means relate with the r generalized coordinate is called a generalized momentum conjugate to r. So pr is nothing but del L by del r dot. So del r dot, from here you can find it will be mr dot simply. So this will be your conjugate momentum. Okay, now let's say there is one more part. If they ask you find the angular velocity also if the particle moving in a circle of radius corresponding to height h0 with respect to xy plane. Now we need to find the angular velocity. If we say that this speed will be fixed at this point, means this r0 is fixed at this height, then what will be the angular velocity? Then see, this r is fixed, then r dot will be 0 and r double dot will be 0. So from the Lagrangian, what we will get? This r dot equal to 0, means this was your Lagrangian equation of motion. So from here this r double dot will be 0 and mass is 1 kg. So just equate these things. It is not given 1 kg, so this term will be 0 because r is fixed. So we'll equate these two things, and we know what is r. From here you can find if this height is z0. If this height is z0, then cos 45 will be z0 divided by r, and z0 then r will be z0 root 2. So substitute in place of r z0 root 2 and equate these two terms. So you will get omega square equal to this, and omega will be under root g by z0. So this will be your angular velocity at z0 height. Now we will study these terms in the next lectures when we will study the Hamiltonian. So this is just to give you an idea about the generalized momentum and the conjugate momentum. So if you have the generalized coordinate q, then it related with pq, then this pq is called the conjugate momentum corresponding to q, only when this pair satisfy this condition. So we'll see this when we learn about the Hamiltonian. So just here remember, if you need to find the conjugate momentum, you just find the simply del r dot. If you need to find the conjugate momentum with respect to r, for r. Okay. So that's it. Let's see the next question. A hoop of radius a rotates with constant angular velocity omega about the vertical axis as shown in the figure. So figure is this. This is hoop, vertical spherical vertical circular ring type structure. So it is rotating like this. It is rotating like this. Now this is bead and this is free to move on this circumference of this hoop. A bead of mass m can slide on the hoop without friction. If g is less than omega square a, at what angle theta apart from 0 and pi is the bead stationary? So we need to find at which point this bead will be stationary apart from 0 and pi. So let's redesign this hoop in this form. So we need to find the theta at which this bead will be stationary when this is rotating. Okay, so let's see the spherical symmetry. So let's say bead is here somewhere. Okay, so this will be your theta 1 from the spherical symmetry, and this is a is r radius, and you will have the phi angle, so r theta phi, and r is fixed. Okay, so r dot will be 0 and r double dot will be 0 because radius is fixed for the bead throughout the sphere or the spherical or the circular ring or hoop. So Lagrangian can be written as half m, this velocity square. This is for the spherical symmetry. You know it is for the r theta phi, and here we assume this as theta 1, so we'll write theta 1 here. So this will be your velocity. Now this height will give you, let's say this y-axis is the reference axis for the potential energy and 0 at y. So this height will give you potential energy. So this height is nothing but a cos theta 1. So this will be your Lagrangian. Now but in the figure it was given theta from this side, means we assume that's why this is theta 1, because theta is given from the, this was a trick actually in the question, that they take this theta from this side. Now to write this Lagrangian in the theta form, so what we do, this angle is nothing but pi minus theta 1. So sine theta 1 is nothing but theta 1 equal to pi minus theta, so it will give you sine theta, and again for this cos theta 1 it will be minus cos theta. So in place of cos theta 1 we can write minus cos theta, and in place of sine theta 1 we can write sine theta. Okay, and this a is equal to r, so we'll substitute in place of r a, and in place of theta 1 we write theta, and or if you are still confused about this theta, then you can see the solution in other way. Means the bead is here, so if your zero gravity is here, so potential energy you can take for this point is negative, so you just use theta here in all the places, and in place of this you can write means this potential energy will be mg minus a cos theta, so it will give you plus mg a cos theta. So that's how you can write in that form. So you will get the same result by both the ways. Will be this, means Lagrangian will be this, half m a square theta dot square plus sine square theta phi dot square plus mg a cos theta. You will get the same result. Now they are saying that this theta should not change, means this should be stationary, then this theta will be fixed, so theta dot will be 0. So first let's write the Lagrangian equation of motion first, then we will see this theta dot and all. So del L by del theta dot will be this ma square theta double dot, and del L by del theta will be ma square sin theta cos theta phi dot square minus ga sin theta. You can see this from this equation. This is simple differentiation. Now subtract this from this, you will get ma square theta double dot minus this plus this. Now see, this theta is fixed, for the means we need to find the position at which it will be stationary. So theta dot will be 0 and theta double dot will be 0. So just substitute here, so this term will be 0 and minus this, so we will get this equation. Is because minus is plus this equal to 0, so this will go also to the right hand side, it will be minus, so we'll get this equation. Now these terms will cancel out and you will get phi dot square equal to g over a cos theta, and this is nothing but omega. So from here you can see that cos theta is nothing but omega square divide g over a omega square, so this will be your cos theta. Now see, it was given in the question, means this was your answer actually. From here you can see this is your answer, because it was given that g is less than omega square a. So if g is less than omega square a, so this will be less than 1, so this will lie somewhere here. Okay, so anyway, this will be your answer. Let's see some other question. Now there is a question can be asked based on the action. We discussed what was action. It was the integral of Lagrangian from t1 to t2, and dt in the matlab it was integration with respect to time. So the motion of a particle in one dimension is described by the Lagrangian L equal to half dx by dt square minus x square in suitable units. The value of the action along the classical path from x equal to 0 at t equal to 0 to x equal to x naught at t equal to t naught is. So Lagrangian is given, we need to find the action. So what was the action? The formula for action was this. Integration of Lagrangian from t1 to t2 will give you the action. Now see, you only integrate this thing when you have Lagrangian in the form of time. So you need to find the expression of Lagrangian in the form of time, only then you can integrate this. But Lagrangian given in the question is this 1 by 2 dx by dt square minus x square. So it is in the form of x. Now we need to remove the terms and make this expression in the form of time. So this L is nothing but x dot square minus x square half. So how can we do that? So it is given that it is moving from t equal to 0 to t equal to t naught and x equal to 0, x equal to x naught. So we can solve this expression integral only if we represent L in the time coordinates. So see, so we need to find these terms in the form of time, then we substitute here and we will get the Lagrangian in form of time. So how can we do that? First we need to solve the Lagrangian and we need to find the Lagrangian equation of motion. So it will be del L by x dot will give you x double dot, and d by dt will give you this, and del L by del x will give you this minus x. Now substitute, means minus this from this, so this will be your Lagrangian equation of motion. Now this is a simple differential equation of second order. You can solve this. This will give you x equal to a sin t plus b cos t. If you have seen my lectures on the differential equations, you know how to get this solution. So just here remember the solution for this kind of equation. X equal to a sin t plus b cos t. Now we use the initial conditions. At x means at t equal to 0, x will be 0. So at t equal to 0, x will be 0. So you will get b equal to 0. Now b equal to 0, substitute here. So you will get x equal to a sin t. Now use the second initial condition. At t equal to t naught, you will get x naught. From here you can find the value of a will be x naught by sin t naught. Now substitute value of a in the equation, in this equation. So you will get x equal to x dot by sin t dot t naught sin t. Now you have the value of x in terms of time, and from here you can just find the first order derivative. X dot will give you sin t will give you cos t. So now you have value of x dot also in terms of time, and for x also in terms of time. Now you will substitute these values in this Lagrangian and you will get Lagrangian in form of time. Then you can find the integration. So just substitute here, you will get this form. Now take this common, it will be cos square t minus sin square t will be cos 2t. Now the action will be integration of this, so it will give you sine 2t divided by 2, and just put the limit 0 to t naught, so it will be this. Okay, just solve this. You will get sine 2 t naught will be 2 sine t naught cos t naught, means this will cancel out and you will get this expression, half x naught square cot t naught. So this will be your action. Okay, so it is A here, action. Now let's see one more question. So question is something like this: a particle of mass 1 kg is released from a height of 1 meter above the ground. When it reaches the ground, what is the value of Hamilton's action for this motion in joule second? G is the acceleration due to gravity. Take gravitational potential to be 0 on the ground. So we need to find the action again, and the condition is given something like this. Let's see the condition. So this is your figure. A particle is released from this height, mass is 1 kg, and it is going downward. So we need to find the action for this motion. So first we will write the Lagrangian for this motion. So say if this height is z, means let's say taken any point in the meanwhile, and this height is z, and this complete height is 1 meter, we know that. And you see that if it is moving in vertical direction, then only one coordinate is changing, that is z. So velocity is nothing but z dot only, and potential energy is also along the z direction. So Lagrangian is nothing but L equal to half m z dot square minus mgz. So at this point the velocity will be z dot and potential energy will be mgz. And to find the action is nothing but integration of Lagrangian from 0 to time t when it reaches here. So this will be your Lagrangian. So to solve this in terms of this, first we need to convert this Lagrangian in form of time, only then we can integrate the same thing. So how can we convert this into time? So we use the equation of motion, simple equation of motion. So initially velocity was 0, so first equation of motion was v equal to u plus at. So acceleration is g, so v will be gt, and v is nothing but z dot. So now we have z dot in terms of time. Now we need to find the z, so we use the second equation. At this point the height will be z 1 minus z, and we will use the second equation of motion, s equal to ut plus half at square. So u is 0, so 1 minus z equal to 0 plus half gt square. So from here z will be 1 minus half gt square. So you have g, so you have z in form of this t, you have z dot. Now substitute these two values here and find the integration. So first we need to find the limit also. So what will be the final time? So when z equal to 0, let's find the time. So for z equal to 0 for z equal to 0, time will be it will go this side and it will be 2 over g. So time period will be under root 2 over g. So this is time period, so we will put the limit 0 to under root 2 over g, and then substitute the value of z dot and z in this equation and integrate dt. So just solve this equation and put the limits, means it will give you t3 by 3, and here you will get minus gt, and put the value of this, then you will get the answer as minus 1 upon 3 under root 2g. So this will be action for this Lagrangian. Now let's see one more question. A projectile of mass 1 kg is launched at an angle of 30 degree from the horizontal direction at t equal to 0 and takes time capital T before hitting the ground. If its initial speed is 10 meter per second, then find the value of the action integral for the entire flight in the units of kilogram meter square per second. Round off to 1 decimal place, g equal to 10 meter per second square. So we need to find the action again. So let's see what is the question is saying. So trajectory is something like this. A particle is launched of mass 1 kg from here at the 30 degree angle, and initial speed is 10 meter per second, and it will hit to the another point at capital T time. Okay, and initially time is t equal to 0. So we need to find the complete trajectory, or we need to find the action for this trajectory. So for that, first we need to write the Lagrangian. So how can we write that? So in the projectile motion, we know that this horizontal velocity remains constant always. So if this is u, then it will be u sin theta and u cos theta. So u cos theta will be ux, so tan 10 is the initial velocity, cos 30 will give you root 3 upon 2, so it will be 5 root 3, and uy will be 10, sin 30 will give you 5. So these are your resolved velocity in the x and y direction, or the component of velocity in x and y directions. Now let's say take any point in between the trajectory and find the Lagrangian for this point. Now see, at this point this horizontal velocity will remain constant and vertical will be changing. So let's write. So x dot is velocity, so this is vx, this will remain constant, this is 5 root 3, and y dot at this point is nothing but, initially let's find, means use the equation of motion v equal to u plus at. So the motion upward is retarded motion, so we'll take minus g. So v is nothing but vy equal to uy minus gt. So this will be velocity for the y component. Now see, Lagrangian is half m, speed is square, so speed is nothing but x dot square plus y dot square. So x dot is this, and plus square of this will give you 75, plus now y dot is nothing but uy is 5, so we already find this 5, this 5 minus gt, g is 10, so it will be 5 minus 10 t square. So this will be your kinetic energy, minus potential energy will be at any height. How you can find the expression? You will use the second motion of equation, s is equal to ut plus half at square. So u is 5 in y direction, t minus half g will give you 5 and t square. So this will be your displacement along the y, so this will give you potential energy, mg h. So mass is 1 kg and g is 10 and h is this from here. So this will be your potential energy. Okay, now this whole Lagrangian in form of time, then you can simply integrate this. But what will be the limit? So how you can find the limit? So this will be your equation. Now see, this displacement along the y direction will be 0 at 2 points only, at here t equal to 0 and at this point at capital T time. So we need to find this time period, so we will put the displacement equal to 0 and find the value of t. You will get two values, t equal to 0 and t equal to 1. So this capital T will be 1 second. So limit of this integration will be 0 to 1 and Lagrangian will be this, and just solve this simple integration. M equal to 1 kg, put m equal to 1 kg, then it will be 75t, and solve these integrations and put the values 1 and 0, you will get action equal to 33.3. Now there is one more thing. See, sometimes, means in the mechanics what you do, normally you need Lagrangian in form of x, x dot and t only. Means you don't need the much higher component, that is x double dot and x triple dot. But there are sometimes question can be asked from that also, means second order derivative and all. So you need to remember this general result. We use in mathematics basically this result, but if they ask you in the paper, then you can solve this also. So you need to remember this general result, means this thing you know for only q, q dot and t, you know this thing. But if you need to find for q double dot, okay, you have some terms in the Lagrangian which is in this form, double dot or triple dot. So you can, how you can find the Lagrangian equation of motion? So this will be the complete differential equation. So for this second order, it will go like this: del L over q del L over del q double dot d square dt square, and if there is triple order also, then you will find this from here. And if there is 4 also, then this is nothing but minus plus minus again plus, and you take the del 4 d4 terms and d5 terms. That's how it will go on. Okay, so that's how you can find the any general term. Okay, so this was the question asked in the gate, that's why I am telling you based on this double dot. So what was the question? The action corresponding to the motion of a particle in one dimension is, so action is given now. So in action we know this is dt and this is Lagrangian and this is limits. So Lagrangian is given in terms of x double dot. Now we are having x double dot term in the Lagrangian, so we need to use that general result to find the equation of motion, where m is the mass of the particle, alpha, beta are constants, and vx is a potential which is a function of x. The position and velocity are held fixed at the end points of the trajectory. The equation of motion of the particle is. So now we need to find the equation of motion when this x double dot is given. So we will use this term, this thing, means we will use the formula, this one. For the second order, you will use this formula. For third order, you will use this formula. For fourth order, there will be different formula. Okay, so it will always start plus from here, then plus minus plus, and again it will start for 3 plus here, then minus plus minus. So that's how you can place the signs. If it is for the 4, then it will be plus minus plus minus plus. So that's how you can write. So it is for the second order double dot, so we'll use this formula. So Lagrangian is given as this: half mx dot square minus vx plus alpha x x double dot plus beta x x dot. So del by x double dot will be simply alpha x. So this will be simply this, and second order will give you alpha x double dot. Then you will find this term, this will be this mx double dot plus beta x dot. This simple differentiation from the Lagrangian, and del L by del x will be this, and just substitute these three terms in this equation. Then you will get the equation of motion. Okay, and this you will get D option. So after solving this, you will get this is your answer. So that's it for today. We'll meet you in the next lecture with some more interesting things. Thank you everyone.